The next topic is restricted least squares. Consider the following two regression models. Please bear with the handwriting in this particular section. yi is equal to beta 1 hat plus beta 2 hat x2i plus beta 3 hat x3i plus beta 4 hat x4i plus ui hat. And then you have another model, yi is equal to a1 hat plus a2 hat x2i plus ui hat. In first model, how many parameters do you have? 1, 2, 3 and 4. So I have written k is equal to 4. In second model, you have 1, 2. K is equal to 2. The bigger model or the model where x3 and x4 are present. In other words, where x3 and x4 are present without any restriction, we call it unrestricted model. And the second model in which we have not taken x3 and x4 is that where we are restricting the values of x3 and x4 is known as a restricted model. In other words, the big model or the model with more independent variables is called an unrestricted model, and the model with lesser number of independent variables is known as a restricted model. What is the restriction? Restriction is that I have not taken x3 and x4. Simple. I am saying there is no need of x3 and x4 and therefore I am restricting them in my restricted model. Now, the first model is called unrestricted model. Second is called restricted model because it has been obtained by restricting independent variables x3i and x4i. Now, the test arises which model is good. Ultimately, you'll have this question while modeling also. So, for example, you are modeling your consumption function. yi or dependent variable is consumption and you have a set of independent variables. So, you might be triggered or you might be intrigued to find out whether I should have a model which has, let's say, income, wealth and prices of goods in the market as an independent variable, or I'm just good with income. So you need to perform a test in order to find out which model to go with. So to test which of the above models is valid, we use f-test, for which the test statistic is this. Now, f-stat is known as r square unrestricted minus r square restricted upon m. M is the number of restrictions imposed. Now here the number of restrictions imposed is 2 because I am imposing restrictions on having x3 and x4 of not having x3 and x4 upon 1 minus r square unrestricted divided by degrees of freedom in this unrestricted model. You can actually compare this f-stat with the s-stat that we did earlier in our earlier lectures, where we were to find out whether we should add an extra variable or not. So there you had r square new minus r square old divided by number of new independent variables upon 1 minus r square new divided by degrees of freedom of new model. This is the same model, just that you have to now draw a synonymity between unrestricted and new model and restricted and old model. So you call the bigger model as the new model or unrestricted model, doesn't matter. You call the smaller model as the restricted model or the old model, doesn't matter. So f-stat can be learned in this fashion: r square unrestricted minus r square restricted divided by number of restrictions imposed, which is number of new independent variables basically, which are there in the unrestricted model. These are 2 upon 1 minus r square unrestricted divided by n minus k of the unrestricted model only. So m is the number of restrictions imposed, k is the number of parameters including intercept term in the unrestricted model. Fine. This is my f statistic. Once you have found out f observed, second step is to find out f critical, and if f observed comes out to be greater than f critical, you reject your null hypothesis. But the question is, what is my null hypothesis? So please have your attention over here particularly. Your null hypothesis in this question is this: restricted or old model is valid and alternative is restricted or old model is invalid. So if you reject the null hypothesis, you would say that you should go with the unrestricted model, or basically the model with more number of independent variables. And if you're not able to reject the null, you would say that my old model is valid. So step 1, whenever you have a question, is to identify which model is restricted or smaller and name it as restricted model. ठीक. And then is to identify which model is a bigger model. Then name it as unrestricted model. Also label their individual R square as R square restricted, R square unrestricted. Find out your F stat. Compare this with F critical. Then accordingly reject or accept your null hypothesis. Fine. This formula is quite understood, but you must be wondering, can I always use this formula? Is R square always advisable to be used? If you remember rightly, we can only compare R square of two models when the dependent variable is the same, and basically dependent variable has the same form and the number of independent variables are also the same. However, this dependent variable rule is quite important. So what do you do if dependent variable of these two models were different? So there are two limitations of this F test. One, the above F test is valid if both the models have dependent variable of the same form. In case dependent variables are of different forms, the F stat is modified into this: RSS restricted minus RSS unrestricted divided by M upon RSS unrestricted divided by N minus K. So this is not very difficult. You can actually reach out to this. I'll explain you how. So your F stat is R square unrestricted minus R square restricted divided by M upon upon 1 minus R square unrestricted divided by N minus K. R square can be written as ESS upon TSS. TSS is always the same, whether it is unrestricted or restricted. We are splitting total variation into both of these models. Minus ESS restricted upon TSS divided by M upon 1 minus R square unrestricted can also be written as 1 minus ESS unrestricted upon TSS. This can be further written as ESS unrestricted minus ESS restricted. TSS can be written all together, TSS divided by M upon, so that would become, so this particular term becomes denominator TSS minus ESS unrestricted divided by TSS upon N minus K. Now this can further be written as ESS is nothing but TSS minus RSS. Agreed? So I'll modify this as ESS can be written as TSS minus RSS unrestricted minus, this will also be TSS minus RSS restricted, this whole, so TSS was cancelled, upon, this can be simple, RSS unrestricted divided by N minus K. So this becomes, TSS will be cancelled by TSS, minus minus will be a positive, so you will have RSS restricted minus RSS unrestricted divided by M upon RSS unrestricted divided by N minus K. So that's an easy derivation. You could write it in any terms. What I'm saying is, this form is to be used only when the dependent variable is not of the same form, because in that case R squares are not comparable. So let's move on to the register again. Second limitation. Second limitation says that since the two models have different number of independent variables, it would be better to use R bar square. Obviously, that is, I think, a very legitimate restrictions. I taught you that dependent variables should be same. Basically, dependent variables should be of the same form. Independent variables also should be in the same number in order to have R square comparable. But in this particular case, in unrestricted model, you have more independent variables. In restricted model, you have less number of independent variables. So in that case, is R square comparable? You must be having this question in your mind. So that is also one of the limitation of this test. that since the two models have different number of independent variables, it would be better to use adjusted R square, that is R bar square, in the above F test instead of R square. Hence, this is another limitation of the F statistic. Now let's do a question on this. The question is this. The researcher sets the following two models, being unsure of total fertility rate as an explanatory variable. So I'll explain you what the model is. So the following two models were estimated to study the determinants of child mortality. Dependent variable is child mortality in a country. The explanatory variables were thought to be important were PGNP, which is per capita GNP of the country, and then FLR, which is female literacy rate, and TFR is the total fertility rate. Let me tell you, child mortality means the number of deaths of a child, number of deaths per live births. And then PGNP is per capita GNP, which is total GNP divided by the population. Female literacy rate is obviously the literacy rate of females. So basically percentage of females who are literate. And then total fertility rate is number of live births which are happening to a woman in her reproductive cycle. So basically, if number of births increase, there is a high risk that the deaths will also increase. So CM, child mortality and TFR have a positive relationship. PGNP is per capita GNP. So if per capita GNP goes up, that means a country's welfare, not welfare, but a country's standard of living improves. Then child mortality should go down, a negative relationship, which is also good. Then female literacy rate is how educated is the mother. If female literacy rate goes up, then child mortality should go down, hence a negative sign. So this is also the negative relationship. Alright, R square of first model is 0.7077. R square of second model is 0.7474. The number of people who were sampled was 25. Fine. So the question arises, should I include TFR as an independent variable or not? So first step, identify which is my restricted model and which is my unrestricted model. Unrestricted model is where there is no restriction. You have all the independent variables. TFR is there. Restricted model is the smaller model where I have not included one independent variable, that is TFR. Once you have done this, and also label R square as this, R square restricted, R square unrestricted. Step 1 is to do this in such questions. Now let's proceed answering the questions. Part 1 says, do all the coefficients have correct expected signs? I just taught you the signs. So yes, all of these have correct expected sign. B part says, test the statistical significance of TFR in model 2. So you have to test whether this coefficient is statistically significant or not. So your null hypothesis will be beta 1, beta 2, beta 3. Null hypothesis would be beta 4 equal to 0. Alternative would be beta 4 greater than 0. Because you know the underlying theory. Underlying theory says there's a positive relationship. Fine. So null hypothesis would be beta 4 equal to 0. Alternative would be beta 4 greater than 0. You will find a T statistic and you should be able to reject the null hypothesis. So B part I am giving you from homework. You should be able to tell that beta 4 is indeed statistically significant. T observed will come out to be equal to 13.24. Okay. Then C part says test model 2 for overall goodness of it. You have to use F test. F test with the statistic involving R square. Fine, I'm leaving that for homework as well. Your F observed will come out to be 20.75. Fine. So you should be able to reject the null hypothesis of R square equal to 0 and say that fit is good. If you're not able to do these questions, please follow my earlier videos to understand how to go about it. D part. D part says, test how will you choose between model 1 and model 2. Use alpha is equal to 0.05. So finally, I have come to testing which model to use. What is my null hypothesis? Restricted model, that is model 1 is valid and alternative hypothesis is restricted model is invalid. My model 1 is this one. which is my restricted model. So my null is that this model is valid. Alternative is that this is invalid. You have R square restricted here, R square unrestricted here. Number of restrictions are only one. One independent variable is restricted, right? That is TFR. So M is equal to 1. And then sample size is 25. You have all the quantities. Let's proceed. I have R square restricted as 0.7077. R square unrestricted as 0.7474. M, or the number of restrictions on the restricted model, is 1, that I have not included TFR as an independent variable. Number of units or sample size is 25. Number of parameters in the unrestricted model K is 4. How 4? Beta 1, beta 2, beta 3, beta 4. So there are 4 parameters. F stat is R square unrestricted minus R square restricted divided by M upon 1 minus R square unrestricted divided by N minus K. Simple mathematics, substitute, and you'll have 3.308. Now next step is finding out F critical. F at the level of significance alpha 0.05. Degrees of freedom in numerator is M 1. Denominator is 21. Now see, if you go to F tables, you might see that there is no such value. But there are values for degrees of freedom 20 in the denominator and 22. 21 does not exist in the table. So what you do is take an average of both. So I have taken average of both the values. This is a very important step. So you can look for the F tables and see that there is no value for 1 and 21. 1 in numerator, 21 in denominator. But you do have for 120 and 122. So I have taken their sum and divided by 2. I'll have 4.325. This is 4.325. This is 3.308. Since F observed is less than F critical, I am not able to reject my null hypothesis. So I say restricted model is valid. So which model should you be using? The restricted one. There is no need of having the unrestricted model, the model with total fertility rate. We'll do the next video involving one more topic. Thank you.